Okay, so we're going to start with number 42. And if you look at my handwritten notes here, which I'm going to break apart, we're going to do it step by step, but I just wanted you to see, and I will send you a picture of all of this. So when you are asked to find the direction and the magnitude of a resultant vector, we had tried putting them head to tail. That is not the way she wants you to solve them. She would like you to solve these using the law of cosine, which you can tell because she gives you the angle, which is the direction of the resultant. So knowing this, then if we want to go ahead and label vector 12 here as A vector, and then vector 8 here as B, we would start with, we want to find the X and the Y of A and B. So what we would do is for A, which this is supposed to be a vector, very ugly. So we want to do 12 times the cosine of 82, because that is the direction of A. And then the sine of 82 will give us the Y, which is, if you just do the math, so 12 times cosine of 82, 12 times sine of 82, thank you, Pumbaa, you get 1.670, comma, 1188. This 12 times the sine of 82. All right, so then you do the same thing for B. And B hat, so 8 times the cosine of negative 12. And it's negative 12 because we're going this direction. Now, you could theoretically do 360 minus 12, and that's going to give you the same answer. This is the way she would like you to do it. Pumbaa, stop. Sine of negative 12 degrees, which gives you the xy of B as 7.83. So again, 8 times cosine of negative 12, and negative 1.66. Okay, so then if we add A and B together, 1.670 plus 7.83, the resultant we get, so A plus B equals 9.5, 10.22. Okay, and then with this information, we can plug that into tangent of theta. So this will give us the direction of the resultant vector. So now that we know the coordinates of the resultant of A and B together, the resultant vector, then now we know we can find the direction, aka the angle of the resultant vector, by taking the y and dividing it by the x and taking the inverse tangent of it. So 10.22 over 9.5 gives us a theta. So our angle, our direction of our resultant vector, 47.09 degrees, okay? So then to find the magnitude is going to be the x squared plus the y squared and the square root of that, right? So because magnitude, m, equals the absolute value of m, the magnitude, equals the square root of x squared plus y squared, right? The change in, sorry, let me see that a little better. So knowing that, then to find, for this, it would equal the square root of 9.5 squared plus 10.22 squared, which the magnitude we get is 13.95. Okay? And then you can see I broke it down step by step here. So step 1, you must find the x and y for each vector. right? You need to be able to find what they are for each vector so that you can add to find the resultant vector. So this is where I solved that, and I got the b, and then I added the a and b together and got my x and y. So then that's the step 2. And then step 3 is to find the direction of the resultant vector, which is tangent of theta equals y over x. We're searching for theta, so you take the inverse tangent of both sides, and you get 47.09 as the direction. And then the last is to find the magnitude of the resultant vector, which is m equals the square root of x squared plus y squared, right? So we go over here, and that's the magnitude of the resultant vectors.